Okay, today we're going to be weighing this Santana 20 I've got with a bathroom scale. Okay, and the first thing you want to do is know what the answer is going to be before you even do it. Huh? Well, here's what I'm talking about. We're going to figure out the weight of the boat mathematically. Okay, it's 6 feet wide on the water line. And according to this, it's about 9 inches depth. And the water line is 16 feet. So we're going to do some simple math to get an approximate weight of the boat. Okay? So now, if the boat were square like a scow, this is 6 feet, and this is 3/4 of a foot. Okay? Which the area of this would be 4.5 square feet. But it's not a square like a scow. Now if it was just a deep V like this, then it would be half of that. It would be 2.25. But it's not that shape either. It's kind of like this. So what we're going to do is take two-thirds of that, and that will come out to be, well, let's see, we'll add a 1 1/8 to this, so that'll come out to about 3 3/8. So that's the number we're going to use. Now, if we multiply 16 times 3 3/8, it's going to be 48, and let's see, and 6. So that is going to be 44. Now, because the boat isn't square, it's shaped like this, we're going to divide it in half, and that's a pretty close approximation. It's not exact, but it's close enough for our purposes. So half of that is going to be 22 cubic feet. Now if we multiply 22 times 64, we're going to end up with, let's see, 12, 8, of course it's the same thing again, 8, 2, 1. So that is 8, 10, 2, 3, 4, 1,400 pounds. Now the keel weighs 550 pounds. So that is going to come out to be, let's see, about 858 pounds. Okay, so what we're looking for is an answer somewhere around between 900 and 1,100 pounds. Will be close enough. Just so we're in the ballpark. And when you do a math like that, whether you're painting your house, trying to figure the gallons of paint, or doing your taxes, you want to have an approximation of what the answer is going to be, so you won't be way off with the final answer. Okay. The boat's supported at 4 points. One there, and same thing on the other side. And then the boat is sitting on these cross members exactly halfway. It doesn't have to be exact, but it just means you got to do a lot more math. Okay, so what we're going to do, we're going to take this lever arm and put it very close to where it's supported. Then what we're going to do is measure out some number, and I like to use multiples of 10 for easy math. So I got that at 20 inches. And because this end is pretty light, we're just going to come over here with 20 inches again, which is right about here. going to put this clamp here to put the scale on, so it'll be concentrated at one point. So we put the scale on there, and we push down till the boat comes up. Okay, and it's coming up at about 140. Now there is some friction involved there. Okay, coming down it's about 130. We'll call it 135. Okay, and then the scale and the clamp is probably about 5. So we'll call it 140. So that's 140, and you got to multiply times 2, so that's 280 pounds that it weighs on this support. Now we're going to do the same thing back here. Now this end is a lot heavier, so we're going to do it slightly different. And your pivot point wants to be quite small, because it'll be more accurate. And we're going to come out on this one 10 inches. And again, we put this over close by where it's supported. And this time, we're going to come out 50 inches. Okay, just 50 inches. We'll put the clamp on here. And we're going to push down with the scale again. So it just comes off the support. Okay, that's about 100 pounds going down. About 80 pounds coming down. So it's somewhere between 80 and 100. We'll call it 90 pounds. Okay, now it's going to be 90 times 5. Which is going to be 450 times 2. That gives us 900 pounds. Okay. So we got 900 pounds for the back end. That gives us 1,180 pounds. In all honesty, I think that number's a little bit high. I don't know why. Probably the friction. But at least we know we're in the ballpark of that other number of 800. So we may check these numbers again, because it seems a little bit high. Okay, cut. Okay, now we want to figure out where the center of the weight of the boat is. So what we do, we measure between the two supports, and it's right at 8 feet. Okay? So now with a little bit of math, we got two supports. We got 900 pounds here and 280 pounds here. Okay? And somewhere in here is the center of the weight of the boat. We don't know where it is. Now we do know this is 8 feet. And from here to here we can call X. From here to here we can call that 8 minus X. 8 minus X. So 280 times 8 minus X should equal 900X. Okay, so that's going to be 64. 1,488 minus 280X equals 900X. We're going to add 280X, so it's going to be 1,400 equals, we'll add 280 to that, so that's 1,180. Okay. Cut. Okay, I made a mistake on my math. This is 2240. This 2240 equals 1180. So X equals whatever 2240 divided by 1100. Well, it looks like it's going to be about 2 feet. So that means X is 2 feet. And this is going to be 6 feet. So what we're going to do is come over here 2 feet. Okay? So this is the center of the weight at 1,180 pounds. 1,180 pounds. Okay? So now, the next thing we're going to do is put the boat on the trailer. But now I know how to place the trailer according to the weight of it. And just for another little check, that should be a little further back than center. And that's a little under 8 feet. So that means that's about 9 feet. So that is probably pretty close. Because we already know that the weight of most sailboats is a little behind the center of the length of the water line. So we're going to go with that. And these numbers could be off a little bit, but it's all just an estimate anyway, just to get us in the ballpark. Now, while we're doing some math, I'm going to just show you one other little trick to see how far the boat would sink when you put some weight in it. Very simple. The water line 16 feet. It's 6 feet wide on the width. It's going to be 96. Okay. And then we're going to divide that in half, because the width times the length on a diamond shape like that is going to be about half. So that's 48. We're going to divide that by 12 to get 1 inch of immersion. So that's going to be 4. 4 times 64, that's the weight of the water, times 4 is 248. So we'll say it takes about 250 pounds to sink the boat 1 inch at the water line. So in other words, you get on the boat with your kid, that's about 250 pounds. The boat's going to go down 1 inch. The keel we took off was 500 pounds, so that means the boat would float about 2 inches higher than it did with the keel on it. These are all approximations. It's just to give you a rough idea of the situation. Hope this helps.